So prove by principle of mathematical induction (P.M.I) that 1 plus 3 plus 5 plus 7 up to 2n minus 1 is equals to n squared. That is, sum of the first n odd natural numbers is equals to n squared. So given 1 plus 3 plus 5 plus 7 plus 2n minus 1 is equals to n squared. So where n is a member of natural number. So we are going to start with step 1. Step 1. Show that the given statement is true for n is equals to 1. So show that the given statement is true for n equals to 1. That's step 1. So you say left hand side. So now if you look at the left hand side, the first term is 1. That is, for n is 1. The first term is 1. So that's it. Then right hand side, we have n square. Right hand side, n square. So when n is 1, that will be 1 square. And 1 square is what? 1. So you have seen that left hand side is equals to the right hand side. So we usually test for the first term only. So to just clarify your proof, you can test for second term, but for PMI, we usually test for first term because it's shown that if it is true for first time, then we need to continue and see if it will be true for others. So now step 1, show that the given statement is true for n equals to 1. So we usually choose n equals to 1 always, most of the time. So now step 2. So you will now say, assume that the given statement is true for n equals to k. So anytime you are showing that the given statement is true for n equals to k, you have to rewrite your question. But anywhere you see n, just put k. So that's what you are doing for n equals k. So I will rewrite that is 1 plus 3 plus 5 plus 7 plus 2k minus 1 is equals to k square. So you rewrite everything but change n to k. That's how you'll be proving for n equals to k. So for n is a member of natural number, but here it will be for k is a member of natural number. So now if you have done this, so sorry, from the first statement you have to conclude before we see the second statement. So as in, since the left hand side equals to the right hand side, you have to conclude that therefore the given statement is true for n is equals to 1. So that's how you end step 1. So after you have shown that is equal, then you have to conclude the given statement is true for n equals to 1. So now the second step, assume that the given statement is true for n equals to k. So I said you will rewrite everything here, just change n to k. So if you have done that, you have proof. So you just say therefore the given statement is true for n is equals to k. So you conclude step 2 also like that. So now step 3 is where we are going to do simple manipulation. So step 3, remember we have 3 steps. So using the assumption made in step 2, using the assumption made in step 2, show that the given statement is true for n is equals to k plus 1. So using the assumption made in step 2, show that the given statement is true for n equals k plus 1. So left hand side. So the left hand side, we have 1 plus 3 plus 5 plus 7. So instead of writing plus 2n plus 1, remember n is now k plus 1. So that will be 2 brackets k plus 1 then minus 1. So that's it, the left hand side. So it's equal to, so I will rewrite all this, but I'll just put brackets here. So that means the step is still the same, but I'll just put brackets there. So this will be like 1 plus 3 plus 5 plus 7, then plus, as in close this first, then plus 2 brackets k plus 1 minus 1. So I'm only rewriting all this step, but I put brackets here. That is, I write the left hand side, just put bracket there. So now the next step, so we know that, so all this we still have it there, so it's equals to, so remember what you have in this bracket now, you just close the bracket here, but what you have in the bracket there is similar to your question but halfway, like this. So you need to complete it by writing this, but that is 2n minus 1. So here it will be 2k minus 1. So that means this will becomes 1 plus 3 plus 5 plus 7 plus, as in all this, it's plus dot 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 plus. So remember you have this, so I have to complete it by putting 2k minus 1. So that is for this bracket. So we still have plus this one there, that's plus 2k plus 1 minus 1. So like that. So the next step, so if you look at everything you have in this bracket here, as in is what you have here, but everything equals n square. So but for this one, everything will be equals to k square because it's in terms of k now, so it's similar to what you have there. So this will becomes, so k square, so that is everything here, k square plus then 2 bracket k plus 1 minus 1. So like that. So the next step, so I have to cut. So next step, I can open the brackets here. So this will becomes, so open the brackets. You can write this step down. So that will be k square plus 2k plus 2 minus 1. So like that. So this will becomes, so 2 minus 1 is 1. So that is k square plus 2k plus 1. So now this is like quadratic equation. So you have to factorize. So watch my video on factorization of quadratic equation to be able to do this step. So now factorize this. So you have k square plus 2k plus 1. So 1 times 1 is 1. 1 plus 1 is 2. So please watch my video on quadratic equation to know how to factorize this, because I'll just do it straight here. So this will be k square plus k plus k plus 1. So like that. Then bracket 2 2. So what is common in the bracket? So what is common in the brackets? So what is common in the brackets now? We have k is common here. So our next step will becomes, so next step, k is common here. So you need to jot this down so you can see step by step. So if k is common, it remains k plus 1. Then plus 1 is common here. So it remains k plus 1. So the next step. So you will notice k plus 1 is here. K plus 1 is here. So just take 1 out. Also, the outside one, k plus 1. So write the second one, k plus 1. So like that. So the next step. So the next step, k plus 1, k plus 1 is k plus 1 square. As in this k plus 1, k plus 1 is k plus 1 square. So now, remember we said we are showing for n equals k plus 1. So if you replace n equals k plus 1 here, so you get 1 plus 3 plus 5 plus 7 plus 2n minus 1. So everything equals to n squared. Remember k plus 1 is n. As in the k plus 1 is n. That's what we are showing in step 3. So now if you look at this, it has gone back to our question. So you will now say the given, since it has given us both the left hand side and the right hand side, so we have achieved. So the given statement is true for n is equals to k plus 1. So finally, this is true by principle of mathematical induction. So after you have solved and show that it's true for k plus 1, so you can now conclude that therefore 1 plus 3 plus 5 plus 7 plus 2n minus 1 equals n squared, for n is a member of natural number, is true by P.M.I. So we have confirmed that. So that's the answer. So we'll see more example.